Now, we know that our a1, y1 is equal to a0 times the term inside the parenthesis and have only x to the power of the even number. The term which x to the power of odd number will go to 0 because its coefficient equal to 0. Now, we are going to find y2. y2 is a function of y1. The way that we can find c and bn for y2 is by putting the function, the y2, the first derivative of y2 and second derivative of y2 into our differential equation. Okay. So the way that you do the differential, the way that you do the derivative of y2 by x, c is a constant, y is a function of x, ln x is a function of x. So when you do the product, the derivative of product. So you've got y1 times d ln x by dx, which is equal to 1 over x. So you've got y1 over x plus ln x dy1 by dx, which is y prime ln x. Bn, n is a constant. So when you do the derivative of this term, you will get bn times n minus 2 times x to the power of n minus 3. You do the same for the second derivative of y2. Take this one. This one also the product of two functions, y1 and 1 over x. This one is the product of two functions, the first derivative of y and ln x. So that's why we got 4 terms there. Okay, but this one is it, you would get bn times n minus 2 times n minus 3 times x to the power of n minus 4. And then, you see these two terms, you can combine them together to get 2x times the first derivative of y. And that's it. Now, you put y2, the first derivative of y2 and the second derivative of y2 into your differential equation. So what would you get is this long equation. So the way that you're going to do next is that try to combine the terms. The term which has the summation, you should put them together. You've got to do rearrange no matter what technique that you can do. And the term which will have the summation, you should put them together. Okay. By doing that, I would get this equation. And now, what are we going to do with that? Okay, this term, to combine them together, you would get only n. See, it's a very, very long equation, but the term itself can cancel out somehow. And if you do rearrange, you would get the problem statement. You can write down the term of the problem statement here. If you can rearrange in such the way that you get x times the second derivative of y plus 3 times the first derivative of y minus xy. This one equal to 0. That's what we did here. This is from the problem statement. It's equal to 0. So any term which is times with this one would go to 0. That makes equation even more simple. And then, okay, next is just that we try to combine these two terms together, but we can't yet because the power of x different. So should we tip x minus 3 to n minus 3 to n minus 1, or we should shift n minus 1 to n minus 3? Which one? To n minus 3. So we should shift this term. So if we want to make n minus 1 become n minus 3, we should replace n with what? N minus 2. So then the next step is just that, plug in the number of n for the last term to be n minus 2. Be doing that, this term would starting from n, from 0 or from 2 to infinity. So even now, x has the same power, but we still cannot combine them together unless this term, we should change it to n starting from 2 to infinity. So that means we got to plug the value of n to be 0 and 1 to this term, and then the rest of the term can be writing down in the term of summation of this starting from n equal to 0 to infinity. See, it's just repeating process. The difficult thing is just coming from the sign, the differentiate of the function, something like that. Okay. Now these two terms, you can combine them together, and then you get that. Okay. This term is coming from when you plus the n value, it's equal to 1, right? If you put n equal to 0, you get 0. If you put n equal to 1, you get minus b1 times x to the power of minus 2. See, this term is from here. This is 0. This one looks even simple. It's not really simple, but even it's more simple. And the thing is that you have the first derivative of y here, and you have y1 here. But your y1 you cannot write down in the term summation because the sequence of your a n is not really in the form that you can write down to the a n. So that's why you have to write down your y in such a way that you can do the first derivative of it. Okay. So what we do next is just go to the process of plugging the function of y, function of the first derivative of y in there and in there, and then you write down again. Okay. And then what do we do next? It's just that rearrange the term, okay, in such a way that you can get the value of it. You put this x into your function there. Okay, this x put into your function because we got to combine each term together. Okay. You put this x there. Okay. And then this term, you put n equal to 3 there. You see that you have x to the power 2 to the power 4, no, you have x to the power 1, you have x to the power 3, this one you have x to the power 3, this one you have x to the power of minus 2. Now, this one, you got to get the lithium of your x, then you can do summation with the rest of the term. So, with this, you put n equal to 3 here, n equal to 4, n equal to 5, n equal to 6, and so on, until then you would get the number like this. And then, what are we going to do next is just that, doing this comparative of the coefficients. The first term that we are going to do is 1 over x squared. 1 over x to the power 2. For 1 over x to the power 2, we have only this term, right? but here we don't have any of 1 over x to the power 2. So we would get minus b1 equal to 0, so our b1 equal to 0. And the next term which we are going to do is x to 1 over x. We have 1 over x somewhere here, 2c. We have b0, and that's it. So we would say that 2c minus b0 equal to 0. So b0 is equal to 2c. Now we do x to the power of 0, so that means a constant. This one we don't have. This one we don't have. We don't have. But we have here. 3b3 minus 1 equal to 0. So b3 is equal to b1 divided by 3, which is b1 equal to 0. So b3 equal to 0. Now we do the term of x. Term of x we have 2c divided by 8. 2c divided by 8. We have 2c divided by 4. We have this one we don't. We have here 8 b4 minus b2, right? Which is equal to 0. This is the comparative of x to the power 1. And from here, we would get this one is cancelled out. We got 1 over 4 plus 2 over 4c equal to 3c over 4. Now, we know that b4 from here, from this equation, we know that b4 is equal to 1 over 8 times b2 minus 3 over 4c. b5, oh sorry, x to the power 2. Next is x to the power 2. This term we don't have. This term we don't have. X to the power 4 is, x to the power 2 we have only from the group of our the summation. So we got 15b5 minus b3 equal to 0. So our b5 equal to b3 divided by 15, but b3 equal to 0. Right? Because b3 is a function of b1, but b1 equal to 0 makes b3 equal to 0. b5 is a function of b3 since b3 equal to 0, so b5 equal to 0. Now the term of x to the power 3. So we do it until we can see the sequence of it. Like b2 is a function of what? b0 is a function of what? b1 is a function of what? Something like that. Okay. Now we do x to the power 3. We got 2c divided by 1 over 192. This one we have x to the power 3 too, so we got plus 2c divided by 48. And then this term we have x to the power 3. So what do? Is just that put x to, or put n to the number of 5, n to 5, into 6, we got x to the power 3. So if n is equal to 6, you got 6 times 4 b1. 6 times 4 b6, which is 24 b6 minus b4 equal to 0. Right? And then again, you do it again and again. Now b6 is a function of b4, and your b4 is a function of b2. So finally you would get c. You would get c. No, actually you would get b. b0 and b2. And then it would go on like that. Now if the function of, you see, if the function of 5, 6, 7, you would need to write down of the term of y1 and the first derivative of y1 in there, because they would have the function of x to the higher power than 3, and then do the comparative of the coefficients and so on. But now we are going to write down our answer for y2, because we know that y2 is equal to c y1 ln x and plus the term there. This term is just from replacing n equal to 0, equal to 1, equal to 2, equal to 3, and so on. And then what you got to do is just plug in the number of b in there. b1, b0, b1, b2, b3, but we know that b3, b5 is equal to 0, right? And then you would see that you would have the term which has the c value, and you have the term that have the b2 value. Actually, you have only c and b2. But we know the relationship between c and b2, right? C and b, c and b0. You see that, you know that b0 is equal to c. If we assume that c equal to 1, then b0 is equal to 2, right? If our b0 is equal to 2, okay, and c is equal to 1, so can b2 is equal to 0.